In this video, we will discuss about the second signal that is activated by UPR. That is PERK. Its full form is protein kinase RNA like endoplasmic reticulum kinase. So, in normal condition, this is present as a monomer. So it is not, this signal does not get activated. However, in ER stress condition, when suppose due to any reason, one of the reason is if the amount of unfolded proteins increases in the in the ER lumen, then this might lead to dimerization of this monomer, and the phosphorylation of this this will create a signal that will affect in two ways. This is usually the phosphorylation of this dimer will leads to two different signals. One that will affect the translation, and another will affect the upregulation of proteins, certain specific proteins. So let us first discuss about the translation, what it will do with the translation. So when the ER stress is observed, cell is not in a normal condition, as we have as we know, and we have discussed about this in the previous videos also. So the first objective of the cell is to first and priority of the cell is to come back to its normal state. So for this, what it will do is, what this signal will do is, first it will down regulate the translation of general proteins. In the previous signal, that is IRE1 alpha, the mRNA degrades the proteins that will be targeted to one endoplasmic reticulum. However, the energy is been utilized by the cell to form the mRNA from the DNA. However, in this case, what it will does is, in this case, energy, this is considered as the most energy. This is considered as the energy efficient step compared to the IRE1 alpha. Compared to IRE1 alpha signal. IRE1 alpha this signaling, because in this the energy is being utilized to generate mRNA from DNA via transcription and mRNA splicing. However, in this case, what it will does is, it will directly affect the DNA and prevent the transcription of DNA to mRNA, prevent the transcription of DNA to transcription of certain part of DNA that is responsible for general proteins. So in this step, the energy will not be consumed. Energy will not be consumed in formation of proteins, in formation of mRNA from DNA, and so in this way the cell's overall energy will also be reduced, as now it will focus its focus mainly on utilizing all of its resources towards making the condition inside ER lumen in the normal as in the normal conditions. And the second step is second signaling that it will activate is ATF4. So what ATF4 does is, ATF4 will also act on the DNA, and what it will does is, it will take care of those proteins that are essential for the cell survival. take control or you can say only control proteins that are essential for example amino acid synthesis. As we know that for the translation of mRNA to proteins we need amino acid that is carried by tRNA to the ribosome, and if the translation of proteins are reduced then we don't need that much amount of amino acid. So what this ATF4 will do is it will down regulate the amount of amino acid in accordance with the down regulation of translation process. At the same time, additionally, what it will does is it will also increase the autophagy or degradation, enhance the degradation pathway, so that it will reduce the load on the lysosome, because some of the unfolded protein will go to the Golgi, and via Golgi they will transfer to the lysosome. So at this in the ER stress condition, because of UPR, lysosome is also overloaded. So to reduce the load on lysosome, what it will does is it will activate this ATF4 will upregulate the degradation pathway, just as in the similar to the case in the IRE1 alpha. It will, in that also it will activate the ERAT pathway. So however in IRE1 alpha, one thing that I forgot to mention you, that if the ER stress is observed for a long duration of time, then cell will consider that ER stress as a new normal stress, and in that case IRE1 alpha will get turned off after a certain period of time. However, for this signaling pathway, it is not yet known whether it will get turned off or not in case of prolonged ER stress. Okay, so this is just two example, like it will upregulate the proteins that are essential. For the examples that I have mentioned is about the metabolism of amino acids and degradation pathway to reduce the load of lysosome degradation. Okay, so I think that is good enough. That information is enough. For the introduction of PERK signaling in ER stress. We'll discuss about the third signal in the next video. Okay, thank you.